Okay, so lecture 25, part two. Last time we made the charts, okay? And then what we're going to do today is we're going to say, okay, hey, you found the charts, okay? Now, which one of those rows is correct, okay? So just make a quick chart here real quick and say we found there's a degree 5, there was 3, and there was 0 with 2 imaginary. Degree 5, there was also 1, 0 negatives with 4 imaginary. And what we're going to do today is you guys are going to use your Desmos and you're going to be able to say, oh, okay, I looked at the graph. This is the correct answer. It had 3 positive real zeros. Okay. So that's going to be our goal with the first part of it. And then the second part of it is we're going to look back to lecture 24 and we're going to talk about how the fact that imaginary numbers have to come in conjugate pairs and how that relates back to that lecture 24. So going ahead and getting rolling. Okay. First thing we have to do, we have a new notation. Okay. And it is max. And then inside of those squiggly brackets, you've got A, B, C, D on forever. And all this wants to know is, if they're asking you that, is you need to find the maximum of the numbers enclosed in the brackets. So all you're going to do is you're going to find the biggest number in the brackets. Okay? So if I'm looking for the max of 1/2, -10, 0, and 5, which one is the biggest number? 5. -10, some people look at that, but it's negative. That means it's small. So 5 is the biggest number. What is the max of -1, -2, and -35? Well, the max would be -1. That is the biggest number that you have there. Okay? So nothing too crazy on that, but that is going to come into play because that's going to allow us to find our interval that our answers have to be between. Okay? So here's where it gets real confusing when you look at this. Okay, theorem says if you have general polynomial function here and a sub n, okay, I factor that out, and I'm left with each of these up here. So basically that's all on the bottom there. Okay, and that's where people look at it and they get really confused. Okay. Then the absolute value of r must be less than 1 plus the max of each of the coefficients. Okay, so you're going to look at each of these coefficients after you factor out this first number that was in front. I factor that out. I'm going to find the maximum number of each of those coefficients, and then I'm going to add 1 to it. So, for example, say I had 2x cubed plus 3x squared minus 4x plus 1. Okay, well, the first thing I would do is I would factor out a 2. When I factor out that 2, I'm left with x cubed. I'm left with a positive 3 halves x squared. I'm left with a minus 2x. And I'm left with a 1/2. Okay, so what I'm going to do is I'm going to go 1 plus the maximum of each of these numbers here. Okay, now, if you notice, it also has these little bars here. Okay, that's because it wants the absolute value of those. So we're going to do 1 plus the max of 3 halves, 2, because it's wanting the absolute value of -2, which is 2, 1/2. So that would be 1 plus 2, which gives me 3. Okay. Now, what that tells us is that all of our zeros here are between -3 and 3. They have to be between -3 and 3. Okay. So that's one way that you can do it. The other way that you can do it is you can do the absolute value of r less than or equal to the max of 1 or the sum of all those. It's the max of 1 or the sum. Okay? So I would look at the same coefficients there if I was doing it this way. And this time I would say the max of 1 or the sum of all those. So 3 halves plus 2 plus 1 half. So what is the max of 1? And then 3 halves plus 2 plus 1 half. So 1 half and 3 halves would be 2 plus 2 is 4. What is the max of 1 and 4? Well, that would be 4. So this way, part B is telling me that all of my zeros have to be between -4 and 4. Okay? So basically what we're doing is we're identifying like, hey, I have a graph here. I know for a fact that all of my zeros have to be between -3 and 3. So all of my zeros have to be between those two there. Okay? So you have two options. You have A or you can do B. And either one works. Okay? It does not matter which one you do, A or B. Okay? So let's go ahead and practice because, again, I know this stuff is kind of confusing. So we're going to practice this here real quick. Okay. Oh, it's saving my image again. Daggum. Mark it back up. All right. So we are looking for the intervals. I already told you what it meant there. The first bound is slightly easier to calculate. Neither bound A or B is always the smallest. So basically, this slide's just saying that you can do either one. It doesn't matter which one you do. Okay, so let's practice one here. All right, we already have a chart. We are using this function up here, and I have already made the chart for you guys down below. Okay, so we did all that stuff. What we're going to do now is we are going to look at each of these coefficients after I factor out the 3. Okay, so if you look down at my next slide here, the first thing that I'm going to do, I've got to factor out the first number. So I'm going to factor out that 3. Okay, now when I do that, I now have an x to the 5th. I now have a 5 over 3 x cubed minus a 9 over 3 x squared plus a 4 over 3 x plus a 12 over. Okay, now we can simplify a few of these. Okay, when I factor that out, I'd have a 3 x to the 5th plus 5x cubed plus 5/3 x cubed, sorry, minus 3x squared plus 4/3 x plus 4. Okay, so the first step, I've got to factor out the lead coefficient. That's what I just did. Once I do that, I'm going to look at the coefficients. 5/3, -3, 4/3, and 4. And I'm going to pick either A or B. It does not matter which one you use. If I'm going to use the A method, my A method in red. If I'm going to use my A method here, I'm going to do 1 plus the maximum of the absolute value of all of these. So it's a positive 3 now, 4/3, and 4. What's the biggest number between all of those there? Okay, well, that would be 1 plus, oops, I don't need to write the max because we know, erase it, sorry. 1 plus 4 is the biggest number, which equals 5. So this means that our zeros are between -5 and 5. They have to be between -5 and 5 is where our zeros have to be located. If you want to do B, B, remember, is the max of 1 or the sum. So I'm going to do 5/3 plus 3 plus 4/3 plus 4. Okay, so that would be the max. 1 or 5/3 and 4/3 gives me 9/3. Okay, 9/3 is just 3, so 3 plus 3 is 6, plus 4 is 10. What is the max between 1 or 10? Well, that would be 10. So part B is telling us that the zeros are between -10 and 10. Okay? So what you're going to do then, once you've identified this, and remember, you only have to do one of them. Okay? I typically like to do A. So I'm going to look at my graph, and I'm going to look between -5 and 5, and I'm going to see if, or see where the zeros are between these. Okay? So I look down here. Remember, this is my table. Whoops. Remember that this right here is my table. Okay, so I either have two positive real zeros, one negative, two imaginary, or have no positive, one negative, four imaginary. So you guys can see here, I used the part A, so I've got -5 and 5. My zeros have to be between those two values there. Okay, so which row is correct? Well, you guys can see that you have one negative zero there. Okay. How many positive zeros do you guys see? Zero. There are no positive zeros. So that tells me that this row right here is correct. For this equation, I am going to have one negative real zero, and I'm going to have four complex zeros. Okay? And that's essentially what we're doing to cap off that lecture 25. Okay, in this next video, you guys are going to see us practice on a couple of them. And then the last one, we will go back and review lecture 24.